Alright, so in this video I'm going to show you how to study molecular interfaces using Intervor under VMD2 here. So I'm going to the plugins menu and I'm going to open the interface modeler plugin. So here is the window, and the first thing I'm going to do is to select a file. I'll be using one vfd.pdb, which is an antibody antigen complex. Alright, so the antibody is defined by the chains A and B and the antigen by chain C. I'm clicking the button telling me that I want to use water molecules squeezed at the interface, and with this I launch the calculation. So it takes about 2 seconds, and as you can see we end up with pieces of information in the graphics engine and also a number of statistics. So if we take a look to the 3D graphics, so I'm going to deselect the molecule, and so we are left with the interface atoms, which belong to 3 groups. In blue we have the interface atoms contributed by the antibody. Let me remove them. In red we have the atoms contributed by the antigen. I'm going to remove them also. And now we are left with the water molecules squeezed at the interface. And so if I remove them, I'm left with the interface per se, which consists of Voronoi polygons in 3 dimensions. And so in fact the green polygons correspond to direct contacts between the 2 partners, the antibody and the antigen, and the red polygon correspond to contacts mediated by water molecules. And indeed, if I plug back the water molecules, so here they are, the water molecules, so you can see that they are indeed involved in the definition of the red facets. So let me put back the partners, and so as you can see the Voronoi polygons indeed separate the partners, and if I move around we can very easily see the so-called CDRs, complementarity determining regions of the antibody here, making up contacts with the antigen. Alright, so let's now move back to the statistics section. So in this bottom left panel we have various pieces of information. First of all, we are told that there is a total of 329 interface atoms. 155 of them are coming from partner A, which is the antibody, and 135 are coming from the antigen. And it turns out that we have 39 water molecules squeezed at the interface. We are also told that the interface between the 2 partners is defined by 3 patches. And so indeed, if we are focusing on the green interface between the partners, as you can see, we do find the 3 patches, right? And now if I plug back the interface involving water molecules, in fact, which is a red interface, we are going to see that the 3 patches are glued together, and indeed the overall interface has a single connected component. The total surface area of the interface is 724 square angstroms. We can now take a look to the footprint of the interface on the individual chains. And so here we are told that chain A has 14 amino acids at the interface. And in fact, if you look at the footprint of the interface onto the chain, we see that we have 3 regions, 1, 2, and 3, and of course they correspond to the CDRs. If we do the same for chain B, we find the 3 regions as well, and these are again the 3 CDRs. And finally, we get the footprint of the interface on the antigen. To conclude, so we may also take a look to the output generated by the calculation, and so we can go to this directory here, which has been preset. And so if I go there, in fact, we are going to find all the files generated. So we get a log file summarizing the calculation, we get the VMD file, which is displayed by VMD, and we get XML files, in fact, listing exhaustively the pieces of information we have discussed, namely contacts and also the geometry of polygons. Naturally, these files can be parsed by Python code, for example, since they are XML files, and exploited for statistical purposes.